Okay, students, in the previous session we just see the FM modulators. There are two methods in FM modulator. One is direct method and the second one is indirect method. The direct method, which we already completed. The direct method, now by using voltage control oscillator, okay. Now directly the voltage variations are converted to frequency variations. Now that direct method which we already completed, and I just give the derivation part of that also, okay. Now the second method is indirect method, okay. Now what is the meaning of indirect method? The indirect method itself, the name itself, now it is getting indirectly, which means, now see here, this is the message signal and this is the carrier signal. Now these two are applied to a narrow band FM modulator, okay. So these two are applied to a narrow band FM modulator. Now the narrow band FM modulator will generate the narrow band FM signal. Now it will generate a narrow band FM signal. Now AC cos 2 pi FCT plus AC cos 2 pi FCT plus beta sin 2 pi FM into T. But where here beta is, whereas here beta is less than 1, therefore this is narrow band FM. Beta is less than 1, this is nothing but a narrow band FM. Now AC cos 2 pi FCT plus beta sin 2 pi FM into T. AC cos 2 pi FCT plus beta sin 2 pi FM into T. Now this is a narrow band FM. When beta is less than 1, this is a narrow band FM signal. So now my question, now this is the narrow band FM signal, but what we want a wide band FM, am I right? Not, beta is greater than 1. So with the help of frequency multipliers, we can convert a narrow band FM into wide band FM. Frequency multipliers of multiplication factor n. Now see here, what is the frequency multiplier? Now this is cos 2 pi FCT, frequency is F. Now this is applied to a frequency multiplier. This is applied to a frequency multiplier of multiplication factor 2. Now which is nothing but, now this is cos square 2 pi FCT, which is nothing but 1 plus cos 2 pi into 2FC into T. So here the frequency is F, input side, and here the frequency is 2FC. So this is the frequency multiplier of multiplication factor 2, then it is multiplied with 2 times. If the frequency multiplier is 3, multiplied with 3 times. Frequency multiplier is 4, multiplied with 4 times. Am I not? Now similarly, now this is frequency multiplier. This is frequency multiplier of multiplication factor n. This is the frequency multiplier of multiplication factor n. So this is the input cos theta. What is output? The output, which is nothing but cos n theta. This is input and this is output. Input is cos theta, output is cos n theta. This is the frequency multiplier of multiplication factor n. Clear or not? Now you tell me, this input is cos theta, output is cos n theta, multiplier factor is n. Now we use this kind of multipliers to generate a narrow band FM signal to wide band FM. Sir, how can it possible? Now see here, can I write like this? This is AC cos, this is angle, am I not? This is angle or argument, AC cos theta. So if it is a multiplier of multiplication factor n, then this is nothing but AC cos n theta, which is nothing but AC cos 2 pi NFC into T plus n beta into sin 2 pi Fm into T. Now this is AC cos theta, now cos n theta. Now you first note down this. Now let us assume, for example, beta here is 0.5 narrowband FM, because beta is less than 1, which is narrowband FM. Now this beta is increased by n times, n beta. So now beta, which is equal to 0.5 into, this is beta which is equal to 0.5 into, for example, this multiplication factor you take 10. Now this is 10, which is equal to 5. Now beta, which is greater than 1, which is wideband FM. Now your narrowband FM is converted to wideband FM now with the help of this frequency multiplier. But the students are asking that, sir, carrier frequency is also changing, but in FM original frequency it should not change. Yes. So whatever the change by a factor of n times, then again you can be decrease that factor, okay, by using a mixer. A concept of mixer is used to change the carrier frequency, and you can get back the original carrier frequency also, okay. So in this way, then the narrowband FM signal is converted to wideband FM with the help of frequency multiplier. Now this concept is given by a scientist called as Armstrong. Therefore, this indirect method is also called as Armstrong method. This is the indirect method or Armstrong method. Okay. This is the indirect way to generate a wideband FM signal from narrowband FM. Now this method is also called as indirect method or Armstrong method. Now what are the parameters gets affected in the process of frequency multiplier? What is the carrier frequency? Carrier frequency is FC. It is changed by a factor of n times. Now what is the modulation index? Modulation index is beta, changed by a factor of n times. Now, what is the message signal frequency? The message signal frequency is FM, which will not affected as it is. Now, is there any other parameters get affected in the process of frequency multiplier? Yes. Now see here, what is the modulation index beta? The modulation index beta, which is equal to delta F by FM. The modulation index beta, which is equal to delta F by FM. But in the process of frequency multiplier, FM is constant, therefore beta is directly proportional to frequency deviation, because FM is constant in the process of multiplier, frequency multiplier. So now modulation index beta is directly proportional to frequency deviation. Therefore, when modulation index is changed, frequency deviation is also changed. Therefore, let us assume here the frequency deviation is delta F. Now, if the multiplier factor is n, it is also changed by n times. If the frequency of the message signal here is FM, so here is also the frequency of the message signal is FM. Okay, these are the parameters gets affected in the process of frequency multiplier. Note down. Indirect method. Okay. Now sometimes the problems are asked in this indirect method also, because some of the parameters are gets affected in the process of frequency multiplier. Okay. Now in your workbook there are two questions which are available in the indirect method. Now classroom workbook question number 1 in indirect method topic. Okay. in indirect method topic. An FM signal represented in time domain as an FM signal represented in time domain as s of t, which is equal to 10 cos 2 pi into 10 power 6 into t plus 0.4 sine 2 pi into 10 power 3 into t. An FM signal represented in time domain as, okay, now this signal is passed through, what is the question is, this signal is passing through two frequency multipliers which are connected in cascade. Two frequency multipliers which are connected in cascade and whose multiplication factors are 5, 4 respectively. These two are passing, this signal is passing through two frequency multipliers which are connected in cascade, Now an FM signal represented in time domain is passed through two frequency multipliers which are connected in cascade whose multiplication factors are 5 and 4 respectively. Then what is asking is determine bandwidth modulation index and carrier frequency modulation index, bandwidth and carrier frequency at the output of the first multiplier and at the output of the second multiplier. This is the parameters he is asking at first multiplier output and second multiplier output. Because this is the frequency multiplier process, now you know which parameters are gets affected in the process of frequency multiplier. Now without applying this, first what are the original parameters? Now what is an FM signal? Now an FM signal represented in time domain is AC cos of 2 pi FCT plus beta sine 2 pi FM into T. Now what is FC? FC is 1 megahertz. What is modulation index beta? Modulation index beta is 0.4, which is less than 1, which is narrow band FM, and the frequency of the message signal which is equal to 1 kilohertz. Now this is the narrow band FM. Now what is the bandwidth here? The bandwidth which is equal to 2 FM, which is equal to 2 kilohertz. But he is not asking here, he is asking at output of the first multiplier and output of the second multiplier. Now the carrier frequency is changed by a factor of 5 times because this is the carrier frequency is affected by 5 times. Now 5 into FC. What is FC? 1 megahertz. Therefore 5 megahertz is the carrier frequency. And modulation index is also affected by 5 times. Now 5 into 0.4, which is equal to 2. And message signal frequency does not affected in the process of frequency multiplier, and the frequency multiplier is same 1 kilohertz. And bandwidth, the bandwidth is also changed because now beta is 2, which is nothing but beta greater than 1 wide band FM, which is equal to 2 into beta plus 1 into FM. Therefore the bandwidth which is equal to 2 into beta is 2, 2 plus 1, 3 into FM is 1 kilo. Therefore 6 kilohertz is the bandwidth. Now this is applied to a second multiplier. The second multiplier is 4. Now the carrier frequency FC, which is 4 times, now 4 into 5, which is nothing but 20 megahertz. And the modulation index beta, which is equal to 4 into 2, which is equal to 8. And frequency of the message signal which does not affected, the frequency of the message signal which is 1 kilohertz as it is. But now this is beta is greater than 1, which is wide band FM. And what about the bandwidth? The bandwidth here, which is equal to 2 into beta plus 1 into FM. So the bandwidth which is equal to 2 into beta is 8 plus 1, 9 into FM, 1 kilo, which is equal to 18 kilohertz. This is the effect of frequency multipliers. Now see, the modulation index is affected, now bandwidth is affected, and carrier frequency is affected, the message signal frequency which will not affected. This is the output of the first multiplier and second multiplier. But if the question is asking directly what is the output of, what is the carrier frequency modulation index bandwidth at finally output side, not problem. Now these two are connected in series, cascade, then the overall multiplication factor is 5 into 4, 20, 20 into 1, 20 megahertz, 20 into 0.4, 8, 20 into 1 kilohertz. No, message signal frequency does not affected. Okay, no doubt. So this indirect method is useful for solving the problems point of view. Okay. Now this is question number 2. Now what is the question number 2 in indirect method topic? A device with input x of t. A device with input x of t and output y of t is characterized by a device with input x of t and output y of t is characterized by y of t equal to x square of t. He is given y of t equal to, what is given? Y of t equal to x square of t. This is nothing but a square law device or a multiplication factor of 2 x square of t. Okay. Now this is a device which is characterized by y of t equal to x square of t. An FM signal with frequency deviation of, an FM signal with a frequency deviation of, an FM signal with a frequency deviation of 90 kilohertz, an FM signal with a frequency deviation of 90 kilohertz and a modulating signal bandwidth, means message signal bandwidth of 5 kilohertz. Message signal bandwidth of 5 kilohertz is applied to this device, and the bandwidth at the output is dash. Okay, and most of the students are doing a mistake, and most of them are calculating modulation index equal to delta f by fm, which is equal to 90 kilo by 5 kilo, which is equal to 18, and a bandwidth wideband fm, which is equal to 2 into beta plus 1 into fm, which is equal to 2 into 18 plus 1, 19 into fm is 5 kilo, which is equal to 190 kilohertz is the bandwidth. Like that, most of the students are doing mistake. This is 100% wrong. This is the wrong. Why? Because he is not asking bandwidth here, he is asking bandwidth at output side. Am I right or not? Now see here. Now the frequency deviation is also, this is the multiplier. Multiplication factor is 2 times. Therefore, the frequency deviation at output time is also changes by 2 times. 2 into delta f, which is equal to 2 into delta f is 90 kilo, which is equal to 180 kilohertz is the frequency deviation at the output side. And a message signal frequency. What is the message signal frequency? The message signal frequency omega, which is not affected anywhere in the process of frequency multiplier. You use this one also, not a problem. And modulation index is also affected. What is the modulation index? The modulation index is affected. Beta is output side, which is nothing but 2 times of beta, which is equal to 2 into 18, which is equal to 36. Now you may use anything. Okay. Now the bandwidth formula, bandwidth of the output side equal to 2 delta f plus 2 fm you use, which is equal to 2 into delta f is 180 kilo plus 2 into fm is 5 kilo, which is equal to 370 kilohertz is the correct answer. Or you may use this one, bandwidth which is equal to 2 into beta plus 1 into fm. So which is equal to bandwidth which is equal to 2 into beta is 36 plus 1 37 into fm is 5 kilo. which is equal to 370 kilohertz. Both are same. You may use this one. This is correct answer. But this is 100% wrong answer. These are the parameters gets affected in the process of frequency multiplier. Which parameters are gets affected? Which parameters which will not affected? First we want to identify. Then the answers are very simple. Okay. Note down.